Good day everyone. Today I will be teaching you how to solve scheduling problems using linear programming and branch and bound method. What is operations research? Operations research is common to management operations to maximize the efficiency of their system. This can be seen in businesses and factories. Many of the problems in operations research can be classified as scheduling problems. The main goal of operations research is to achieve the best performance of the system given a set of variables and constraints. What are some of the uses of operations research? First, scheduling and time management problems. Second, urban and agricultural planning. Third, supply chain management. Fourth, inventory management. Fifth, risk management, and many more. But for this presentation, we would only be focusing on scheduling and time management problems. What are some of scheduling problems? These could be problems concerning employee shifts and what product to prioritize, producing in a product line, and many more. Linear programming is a technique in operations research that allows the scheduler to optimize the objective function of the problem. Although it was used way before World War II, it was only popularized after it was used in World War II to deal with the allocation of resources, transportation, and scheduling. The main goal of linear programming is to find the optimum value of the linear expression of the problem. What are the characteristics of linear programming? There must be an objective to the problem. Example of this is minimizing the cost or maximizing the profit of the problem. The limitations of the problem should be in inequality form, which means that it has to be in quantitative form and it has greater than or equal to, less than or equal to, or of that sort. The variables must be non-negative, which we will be furthermore explaining later. The variables must be linear to each other, and the factors included should be finite. For factors that are infinite, it is impossible to find a feasible solution. What are the advantages of linear programming? Linear programming guarantees you a solution to a problem. It is possible to solve a large-scale problem with linear programming as long as it meets its required characteristics. And plus, there are a lot of software that can help you solve linear programming problems that are simple to use and easy to understand. What are the disadvantages of linear programming? Linear programming requires the objective function and the constraints to be in linear equations. Sometimes the solution will give fractions which are not possible for problems such as trucks, pieces of equipment, or other things that cannot be divided. It can only solve single objective also. I would be presenting a sample problem of linear programming from Hassan and Arafin. The sample problem is about a police scheduling problem, and the goal of the problem is to find the minimal number of police officers needed to satisfy the required number of officers on duty per day or that particular time slot. What are some of the constraints of the problem? Each officer has to work 8 hours straight. There would also be non-negative constraint because there can never be a negative addition of officers. What do we mean by each officer has to work 8 hours straight? For example, if an officer starts working at 8 a.m., his shift ends at 4 p.m. As you can see, at the time of day, at a particular time slot, there's a assigned variable which corresponds to this. The equation of these constraints are as follows. These constraints represent the minimum number of officers on duty per day or at that particular time slot. X6 plus X1, as we can see, this is due to the officers need to work 8 hours per day and so on and so forth. Now, how do you solve linear programming using Excel with the same particular problem? First, we put our variables on the Excel. As you can see here, x1, x2, x3, x4, x5, x6. These are the variables that we are gonna change. Second, we put the objective, which is to minimize the number of police officers needed. Third, we put the constraints, as you can see here. From cell 15 to cell 20, we can see that these are the constraints given by the problem. Now, why do we have constraints from cell 21 to 26? These are the non-negative constraints because we cannot add a negative addition of police officers. Now, how do we solve this? First, we have to put solver. If you don't have solver, you just have to go to the data tab and click on analysis tool and click on solver add in and press OK, and it will download itself. Next, how do we solve it using the solver parameters? First, we have to set the objective, as you can see here, which is to minimize. And second, we have to put to minimum, since that's the problem. That's the thing that we are looking for in the problem. By changing variable cells, which are variables from B2 to B7, subject to constraints, which are the cells in B15 to B26, greater than or equal to the cells in D15 to D26. Next is we have to select the solving method as simplex linear programming. The last step is just click solve and wait. Now, as you can see, after clicking solve, we have our variables here set and our minimum number of police officers here as 19. In order to double check, we bring back the original problem. Now, using Mathematica software, the optimal basic feasible solution is x1 is equal to 3, x2 is equal to 3, x3 is equal to 7, x4 is equal to 0, x5 is equal to 4, x6 is equal to 2, with the minimum value of z is 19. As you can see, we have the solver did its work and we have the same values as the original problem. For the next one, in branch and bound method, it is under the family of integer programming. It maps out all your possible solutions, and it uses tree and search method to eliminate solutions that are not feasible or suboptimal. The number of possible solutions here can be written as n factorial, n being the number of products. To find the individual delay time, first add all the days needed to produce all products, then subtract their respective due date to the sum. The total delay time can be represented as d subtotal is equal to d sub a plus d sub b plus d sub c. Now, what are the steps in doing the branch and bound method? Step 1 is to figure out which product to produce last by mapping out all 3 products and finding the individual delay time of the product. Step 2 is to eliminate the sequences which have a delay time of more than the least you were able to discover. Step 3 is to repeat the process of step 1 and step 2 and to find the correct sequencing of product to procure the least amount of daytime. What are the advantages of branch and bound method? Branch and bound method is quick to eliminate solutions that are suboptimal, and it is also easy to use and understand. Now, this is an original example problem of the branch and bound method. As you can see, we have 3 products here with their respective time to produce and their respective due dates. It is important to note that the product line here is non-preemptive, which means that if you start producing product A, it has to finish producing product A before it can be stopped, or it could be replaced to produce product B. As you can see here, there are 3. The first step to do is to map out all the possible solutions, which is if we produce product A last, if we produce product B last, and if we produce product C last. Now, if we produce product A last, we have to find the total delay time that it gives us. In order to find this, we have to add all the products time to produce, which is 5 plus 7 plus 14 is equal to 16, and minus it to their respective due date. So we know that if we produce product A last, it will be produced at the 16th day, but the due date of product A is day 12. So 16 minus 12 is equal to 4, which gives you a delay time of total of 4 days. And for product B, we do the same. It gives us a delay time of 9 days. And product C, the same, 6 days. We have to remove the solution that tells us to produce product B and product C last, because it is suboptimal compared to the first solution. For the first solution, we have to find out naman if we will produce product C second or product B second. Now, in order for this, is we have to find out at what day is product C produced. Product C is produced at the time to produce of B plus C, which is the 11th day. Now, the due date of product C is the 10th day. So 11 minus 10 is equal to 1. We will add that to D is the delay time of 4 already. It gives you the delay time of 5. Next, we do it on product B. The due date of product B is day 7. So we minus it. 11 minus 7 is equal to 5. So we add it to the delay time of 4 already. The delay time is equal to 9. We have we have to remove the solution that gives you the delay time of 9 because it is suboptimal to the other solution. After that, now we can find the solution to our problem. The solution to our problem is to produce product B first, product C second, and product A last, which gives you a total delay time of 5 days only. That is all. Thank you.